All right, still in lesson 1-3, problem 6. And again, for me, that means 6 is 1.3.18. All right, so this is just a one-step problem. Write the absolute value function as a piecewise definition function with linear parts. So how does this absolute value of 2x plus 3 graph work? Well, you know, sometimes this might be a good place where I can demonstrate a program that I like to use when I'm kind of thinking, well, how do I do that? And the program I'm thinking of, some of you hopefully have used it before, it's called Desmos. So if I go to desmos.com, and when you get there, I want the graphing calculator. So there's a button right there that says graphing calculator. Just gonna double check here that I'm sharing the right screen with you. And I think I am. So on this screen, I want to graph the equation y equals, absolute value here is ABS, and then in parentheses, we had 2x plus 3. So you can see on this graph, the plus 3 looks like it did a 3 to the left shift, and then the 2 is like a slope. Got my toolbars all in my way here. Let me put up and move around. All right. So there's my. Oh wait, that's not. This is 2, 4. So this is this point right here. Let's see what this point is. If you click on it. So -1.5. Well, where can you get that from over here? So if you have the 2x plus 3, if you subtract that 3 to the other side, then divide by this 2, there's your -1.5. So there's that. And then this 2 in front of the x is like, this could be like a slope. So what's my slope here? Let's see if we can find some whole numbers to work with. So like right here, this would be -1. And then up to there. So if I go over 1, these are going, so these are going, these little marks here are halves. So from here to there would be 1. Oops, lost my tool here. So this is 1, and then how much is it from here up to there? That's 2. So that's like a slope of 2. So the 2 in front of there is still my slope. All right, so we're supposed to do, if we then go back to our problem. So hopefully you remember all that we had. Again, let me just double check, and then yep, you're seeing the right screen. And so what we've got here now, again, remember what we had? We had from Desmos, we said this was over here at like -1.5, and then these slopes were like 2, so it was like over 1 up 2. All right, so we're asked to do a piecewise function for this. So here we go. Got all this stuff in there. Let's erase some of this out of the way over here. All right. So when x is less than, where does this change direction here? So we have our 2 parts. One is this left arm, And then one is this right arm. And this point right here is negative 1.5. So right down here, because my x's changed directions, these are going to both be at negative 1.5. Now, what goes in here is my equation. On the right side, that might be easier to do because we could actually see the y-intercept. If you remember, that y-intercept was the 3. So on this right arm over here, that's just your 2x plus 3. Your left arm, it's a negative 2. But then what would your y-intercept be if you kept going to the left side down below? If you kept going, let's get another color here. If you kept going down here, where would this be down here? Well, if this one's up at 2, symmetry tells me that this one down here, because it should be at the negative 2 in this case. Oh, wait, this was at 3 up here though, right? So this is negative 3 down here. So let's put that in there. And let's see how we did. But all that symmetry, all those things, if you can look at it and find a faster way, again, I encourage you, if you can do it in your head to figure it out, you can always come up with something faster. But that's what we're talking about here on this problem. Piecewise function, absolute value.